Welcome everyone to our free GMAT Quant webinar. Whether you're here for the first time or you've been to one of our webinars before, thanks for joining us. My name is Andrew and I'm one of the Student Success Advisors here at Ready4. I consult with students, connecting them with courses that best suit their needs, and I'm happy to have the chance to host today's webinar and give you all a chance to meet one of our talented instructors. So let's get started. A couple of things to know before we begin. You're all muted, so depending on where you are, anything you say out loud might look crazy to those around you, but it's not going to get our attention. Instead, take a minute to find the question box. This will be an important tool for you today. Any questions you have about the content of today's lesson, the GMAT in general, or about our courses, you can type them right into that question box and we'll either respond directly or during our Q&A session at the end. When it's time for you to cast your vote, as we're doing in-class examples, you're also going to type your answer right into that question box. We're going to be sharing these slides, answer explanations, and a handout exploring our services at the end, so don't forget to download those as well. And finally, the session is being recorded, so be on the lookout for our follow-up email after class if you'd like to view the recording or the handouts, especially if you're tuning in now from a mobile device. Here's what we're going to cover today. I'll start by telling you a little bit about what we do here at Ready4. Then I'm going to pass things off so you can see one of our experts in action. While these free webinars aren't going to teach you everything you need to know for the exam, they provide a solid intro to the test, and you'll have a chance to meet one of our instructors and get an idea of what our courses are like. I promise that whatever stage you are in your GMAT prep, you're going to take away some strategies that you can apply now and continue to improve on throughout your practice. If you enjoy the session, stay to the end and I'll jump back on and provide a little bit more information about our courses. We even have a special surprise to say thanks for being here. That's going to be at the end of this session. All right, a little bit about us. Ready4 was started out of MIT back in 2013, and our goal ever since has been to make test prep both more affordable and more accessible for students. That's why we offer a number of different prep options based on your needs and your budget as you prepare for the exam, ranging from our top-ranked practice tools designed to measure and adapt to your performance so they're better than any book, to our fully immersive prep courses, whether on demand or live with the best instructors in the industry. We're providing a flexible, mobile-led learning experience to fit the needs of any student, regardless of your location or your background, but I'll talk more about our services at the end. I want to introduce you now to our instructor before we begin the lesson. So today's session will be led by Richard. Richard has an 800 score on the GMAT. That's a perfect score, and he has 15 years of experience preparing students for the test. Students love Richard's straightforward approach and the way he methodically breaks down problems. He has a ton of content knowledge, and you're going to see that in today's lesson. All right, now I'm going to pass things over to Richard. But remember, if there's anything that I can do to help you out, I'm right at the other end of that question box. Thanks, everyone, and good luck.
All righty, thank you. Let me get my screen share going, and then we can proceed. So yeah, thank you. So my name is Richard. I am teaching for Ready4 GMAT. I teach the live GMAT classes primarily. And as Andrew, as he said, we have I have taken the GMAT 3 times, gotten 750, 778, and 800. I've also taught well over 15 years. Actually, it's probably more like 17 or 18 years at this point. Taught well over 300 classes, probably over 3,000 students, and averaged over 92 points in improvements. If it's over 100 now, that's even better. So I do want to talk a little bit about the GMAT, just kind of in general, and then jump into some math questions, just to show you some idea of the different techniques that we teach in the Ready4 class, and get a little bit of a feel for what the class experience is like, and give you guys a chance to interact with me and learn a little bit more about the class. If you do have any questions, feel free to type them into that question box. And they will be responded to one way or another. I do keep an eye on that as I'm going along. If I don't answer immediately, it doesn't mean I'm ignoring you, it just means I'm probably in the middle of something. If you do want to introduce yourself, that'd be great. Maybe what your name is, where you're located, Anything else about yourself that's interesting? I do like to keep things as interactive as I can in class. I do keep an eye on that. In the past, I've had students from Colombia, Peru, the exotic land of America, Canada, the Netherlands, Kenya, Dubai, India, Singapore, Taiwan, kind of all over the globe, actually. And it's one of the reasons why I'm really excited about teaching for Ready for GMAT is I get to do this and meet people in my classes from all over the world. So we have a person from Boston, a person from Florida, cool. So that's actually really exciting. Now for the GMAT itself, so good news, the GMAT is now slightly easier than it used to be. So now it's actually 3 hours, actually only 3 hours long. Well, 3 hours and 30 minutes. It used to be like 4 hours. They cut 30 minutes from it. They cut 10 minutes from the verbal and 13 minutes from the math, so it's 23 minutes shorter. You can choose the order of the sections. That's actually a big plus. They made that change a little over a year ago, I think. And then one other note, there is an integrated reasoning section which tests charts and graphs and that kind of thing. It's actually totally separate from the main part of the GMAT. Your total GMAT score is based on your quantitative score and your verbal score only. And the quant and the verbal are basically 50-50 in terms of importance. My recommendation also is that you go off of the actual raw score and not the percentile, but maybe that's just my opinion. So the GMAT's an adaptive test, and it's very important to understand how this works. So at the beginning of the test, you typically start at sort of a medium level of difficulty. The test just kind of grabs a question randomly and throws it at you. And then you can either get the question right or get it wrong. If you get questions right, what happens is your score will just move up slightly, and then the test will pick another question randomly, and it's trying to kind of match the difficulty level of the questions with your score at any given moment. If you get a question wrong, then your score will go down a little bit, and again, it'll pick questions randomly to try to match your difficulty level. And so what happens is, in theory, is you do kind of a little random walk where the test is kind of slowly converging on what is considered your true ability level. And then the level that you wind up here at the end is going to be something between 200 and 800, which is going to represent your GMAT score. So this is actually a slight oversimplification because there's actually two tests. You have the quant test and the math and the verbal test. Each of them has their own score. That score actually goes between 0 and 60. So actually you wind up doing this twice, once for the math and once for the verbal. You can do them in either order, as mentioned earlier, and they are separate from each other. So no matter what your performance was on the verbal, when you start the math, you start over with a brand new question at medium level, a brand new blank slate, or vice versa. If you do the math first, it has no impact on your verbal performance. Okay, they're considered separate tests. So because of this format, you do have to do all the questions one by one. You do have to go in order. So there's no strategy like skipping skipping hard questions to do easy questions and then going back to the hard questions. That's not available. You have to do all the questions one by one in order as you get them. That means that guessing and guessing strategically is a very important part of doing well in the GMAT. You should know how to do most of the questions that you encounter, but you should also expect the unexpected. There will be some problems you don't know how to handle, at least not within 2 minutes on the real test. And for those types of questions, you need to have a technique or a strategy that'll help you make an educated guess and be able to move on with some equity in your guessing. Okay. So let's get into some of the insider secrets. So a lot of GMAT, there's a certain, of course, obvious foundation level of knowledge that you need to have, but it's not about how much math you know. It's not about how much grammar you know. Once you get to sort of a certain level of math, like maybe middle of high school, I would say, maybe 10th grade in high school, you actually really have all the tools you need to be able to solve the questions on the GMAT. What makes GMAT hard is the complexity of the questions, the use of confusing language, deceptive language even sometimes, the way they like to stack or layer issues in a question. So it's more about your ability to read and analyze information quickly and organize that information and to reason your way as you process that information more than about your knowledge. So just kind of a short checklist of things in math that you probably already know how to do. You probably know how to add and subtract, multiply and divide. You probably already know the definition of even and odd numbers, although maybe there might be a wrinkle or two that you don't know just yet. But basically, you're going to know almost all the basics already. All right. There's a few things that you may be less familiar with, like statistics, for instance, but we do cover that in the class, and I do explain all the definitions that you need for those concepts. So let's get into the strategies and the questions, which is, I think, what you guys are really here for. And also the part that I just love is doing the questions with you guys. So I'm going to show you the questions one by one. And what we'll do is I'll set my timer, and I'll use about 90 seconds, I think. On the real exam, you have closer to 2 minutes per question. But in these kind of webinars, I like to go a little bit faster just to challenge you guys, and also just so we can get through slightly more questions in the same amount of time. You can put your answer in the question box. So don't use the number, use A, B, C, D, E. Only those can be the answer. You get no credit if you put in the number, but you don't put in the letter B, for instance. Yeah, and then I'll go through the problem afterwards and show you guys a solution, and we can talk about what happened. So basic breakdown in the quant is between the two main formats of questions, problem solving and data sufficiency. Problem solving is more like a normal math question. They ask you the question and they give you 5 answers. And then you pick the answer choice that gives you the correct value, typically. Data sufficiency questions, a slightly different format. Now it does test the same concepts, so it's still arithmetic, algebra, geometry, word problems, that's all the same. But what they do is they actually switch up the way they test the concept. So they give you the question and they give you a couple facts, and then they want you to choose which fact or facts are enough to answer the question that they asked you. So we'll be doing some examples of both. So we got 3 or 4 examples for problem solving, 3 or 4 examples for data sufficiency. So we'll be doing both of these today, now. Anyway, let's see. So common strategy for questions with variables. Okay, so this is really the key issue, is that doing calculations with variables is just a little bit more abstract than doing calculations with actual numbers. And I want you to realize that this is true regardless of how good or bad you might be at mathematics. Calculation with actual numbers are always easier than calculation with variables. That's the reason why we teach kids how to do arithmetic in 1st grade and 2nd grade and not teach them algebra until 8th grade or 9th grade. So whenever you see a problem with variables, you definitely have the chance to plug in numbers and use the numbers that you chose to do the calculation instead. I'm very fond of 2 and 3. Those are numbers that I use quite often. I also use 5 sometimes, 10 sometimes. And of course, special numbers like 1 and 0 can have unusual effects in the question, but actually can be quite handy sometimes because they're easy to work with. And also negative numbers and fractions are available sometimes too, depending upon the type of question. Okay, so our first example. So they ask you which of the following expressions has the minimum value. Okay, so make sure whenever you read a question that you identify this part of the question first, which is what I call the question stem. The question stem is the question part of the question. And when you do that, make sure that you, on your scratch paper, write down some label that represents what the question's asking for. So like on a question like this, I would probably just write down min, M-I-N, and then a question mark, and then a list of the 5 choices, A, B, C, D, E, and then you can work from there. Okay, so I'm going to set the timer now, and I'm going to, I think I can maximize the screen if I turn off the camera, so I'll do that, let you guys work. Okay, good luck. All right, that's interesting. So I have about 2/3 of the group chose B and about 1/3 chose C. So these are the two answers that people are going for. Yeah. Now there's actually a couple different ways you can go on this. So first of all, there is a fact that you have to respect. And this is actually very important whenever you plug in numbers. So if you plug in a number, you're essentially cheating in some sense because you're putting in information that was not originally in the problem. So whenever you do that, you have to sort of back test. In other words, you have to confirm that the number that you plug in fits the information that's already in the question. So like in this case, we're told that P has to be between 0 and 1. So you can't just plug in any number you like. You can't plug in 2 or 3 because they don't fit in that range between 0 and 1. Now, when you do plug in a number between 0 and 1, you can do either a fraction or decimal. Either one is okay. I've actually done both on this problem, and whichever one is more convenient for you is okay. I think I'll go with a fraction this time. So let me pick this. I'm going to pick 1/4. And the reason why I'm going to do that is because I know that I need to take a square root later on in the problem. So this symbol here, like P to the 1/2 power, represents the square root of P. So just as kind of a little head start, I'm going to use this over and over again. The square root of P is going to be the square root of 1/4. That's going to be 1/2 actually. Okay. So I'm going to use that later on when I go into the 5 choices. Now, so according to what I just calculated, A is 1/2. B is going to be 1/16 because you're going to take P squared. C has a negative value. So what that means is it's 1 over P to the 1/2, which means it's 1 over the square root of P. So essentially what you're doing is you're taking the reciprocal of that number. So this is the same as choice A, but it's the reciprocal. So it's actually 2 over 1 or just 2. D is P to the 3/2 power. So there's a couple ways of looking at that. One way is that it's the square root of P cubed. I think that's actually probably the most straightforward way. So if I know the square root of P is 1/2, that means I know this is 1 over 8. And the last answer, E, there's no calculation required. It's just the original number, 1 over P, 1 over 4, sorry. So we're looking for the minimum. C is the biggest, B is the smallest, and choice B is the correct answer. So if you do it with a decimal, you're going to wind up with slightly different calculations along the way. You should get the same final result though. And so here's the real secret behind this type of question. When you look at the number line, I should have given myself more room. That's okay. When you pick a value for P, that's like say here. When you look at P squared, it's going to get smaller, right? Because when you take a number less than 1 and multiply it again, you wind up getting a smaller number. When you take the square root of P, you wind up getting something bigger. And that's really what this question is all about, is recognizing that this relationship between P squared, and the square root of P actually kind of goes in the opposite of the normal direction. Normally for bigger numbers, you know, if I pick some number like, I'll call it X or something like that. Normally if you take the square root might be smaller and, you know, X squared might be bigger, for instance. That's the normal relationship. So they want you to recognize that relationship is being reversed in this question. About some of the other answers, P to the 3/2 power. This is kind of a sneaky one. But actually, P to the 3/2 power should be between P to the 1 power and P to the 2 power, because 3 over 2 is in between 1 and 2. And then the last one here, the negative exponent, means it's the reciprocal. And so since it's the reciprocal, it'll be somewhere like, actually it was 2, wasn't it? P to the minus 1/2, be something like that. So essentially what you're doing is, what you're doing to try to find the minimum value is you're trying to find the largest exponent, right? And if you find the largest exponent on this question, so someone is asking if there's a relationship for ones that are greater than 1. So if you look at my example for X, which is a number greater than 1, then the relationship is actually much more simple because bigger exponents always mean a bigger number. Yeah, it's for numbers between 0 and 1 where bigger exponents make a smaller number. So that's the concept that they're really testing. Now, when you're approaching test, in my opinion, if you get the concept and you truly understand how the number line works, I would actually just draw this picture and just put the points down on the line, and don't even assign values to them. Just make sure you put them in the correct spacing from left to right. And that's good enough to pick the correct value. But if you're not sure about the concept, or you just are a little shaky on it and you want a little bit more solid confirmation, then go ahead and plug in the number and do the calculation for the 5 answers. And that way you'll be sure that you're picking the minimum value. Okay. And there's actually also the third approach, which is kind of a hybrid, which is you might start by plugging in and start using these calculations, but then about halfway through the problem, the light bulb goes off and you say to yourself, oh, wait a minute, it's these relationships are inverted. Bigger exponents make smaller numbers. At that point, you can abandon the plugging in, go back to the concept, and just pick the one that has the biggest exponent. I'm a big fan of being flexible, believe it or not. Plugging in answer choices. So this is something I think not enough people really appreciate, which is that when you do algebra, there's really 3 steps in an algebra problem. And this might be a little bit annoying to people, back when they took algebra the very first time, when they're 14 years old or something. But the first step in the problem is to translate the information into an equation. So if it's a word problem and it says Bob is 3 years older than Sally, you have to write down some equation like B is equal to S plus 3. That's the first step. Second step is to solve the equation. So, if you have a variable, you try to isolate it by subtracting and dividing until you get that variable by itself on one side of the equation. That's called solving. Right? Third step in algebra that everybody forgets: checking. So checking means you take the number that you got and you put it back into the original equation. So I'm going to do a very simple example, and you guys should get the point. So if I have an equation like this, x plus 3 is equal to 5. If you're solving it, the way that you learn how to do it is you subtract 3 from both sides, and you wind up getting an equation like this, x equals 2. That's the solving, right? But what's the checking? The checking says you take this number 2 and you feed it back into the original equation. So the checking step would say, oh, what if I take 2 plus 3, does that equal 5? Right? And if it does, that proves you've actually got the correct answer. Okay. So when I was in high school, I was a real smart ass, and I thought I was smarter than my teachers, right? So what I did was I would do the solving step, and I would never do the checking step, because I felt like I already knew what the answer was. I felt like doing this was kind of a waste of time. Okay, and to be fair to my younger self, I probably was right. But on the GMAT test, that's actually not right, because on the GMAT test, you've already been given the number, right? So in other words, they're going to give you 5 answer choices, A, B, C, D, E, and you're going to have 1, 2, 3, 4, 5 as the answers. So you don't actually have to do the solving at all. You've already got the answer. All you need to do is just check and see if it's actually going to fit into that equation. So the real test is, if you have a correct answer, it means that you can plug it into the equation, and the equation is true. If the equation is true, you have the correct answer. On the other hand, if you plug a number into the equation and the equation is false, that means you have an incorrect answer, and you can just cross that answer out and test on something else. Okay? So let me set you guys loose. So this problem uses the word could. So the key thing about the word could on the GMAT is that there might be many possible answers, but only one of them will be in the 5 choices. So instead of trying to find every answer that might solve this equation, just go to the answer choices and plug in until you find one that works. When you find one that works, because it makes it true, you can just stop right there. There's only one right answer, and you're done. Okay, so 90 seconds. Okay, that's 90 seconds. And looks like we have C, CC. Okay, great. C is the correct answer. And there's a couple things that you should be aware of. So first of all, you cannot divide by 0. So immediately you realize that choice E cannot be correct because you can't have 1 over 0 here. And then in a more subtle way, but the same thing is true for this term right here, n cannot be equal to -1. So n plus 1, if n was -1, it'd also be 0, and you can't divide by 0. And then for the same reason, on the right side here, we have n plus 4, that cannot be 0. So that means that n cannot be -4. So that actually narrows things down quite a lot really fast. So you've only got 2 choices to even consider trying B or C. And at this point, let me just point out with the logic based on of process elimination that you can actually test either number. It doesn't matter which one you test. If it's the right answer, you're done. It's the right answer. But if it's the wrong answer and it makes the equation false, you're also done because then you can eliminate that choice and you would know that the other answer is the correct answer. Okay. So looking at choice C, for instance, here's what we're going to find. We're going to find that -1/2 minus 1 over -1. Whoopsie, sorry. That'll become a +1 is equal to 1 over 2. But that's actually true. So -1/2 plus 1 is equal to 1/2. And that proves that C is the correct answer, and we can just stop right here. No need for testing B or any other choices. Okay, cool. So next, when you have percentages questions, make sure you know what the percentage is actually out of. So in this case, the question itself is asking how many students take French, but the graph is showing you the percentage of students. So you've always got to be very careful when you look at graph questions that you're not confusing the actual number versus the percentage, because the percentage and the actual number don't have to be the same thing. And then I know it's a little bit gray on the screen, but French here is the darker color, which means it's the one in the middle. Okay, so that means you want to calculate this area and this area and this area and find the total of those for the total number of students. Okay, so you have 90 seconds. Okay, good. So yeah, go ahead and put your final answer in. So far I've seen D, E, D, and B. Interesting. Okay, so let me try to capture what I think are maybe some fair numbers. Another D, okay, good. Another B. So in terms of this French here, I would say this is maybe Yikes. Let me try that again. I would say maybe that this bottom number here is something like 25. This is something like 85. Okay, so that means that if you take the difference, it should be around 60%. And then for this one, maybe this is about, maybe this one's about 35. Maybe this is about 75. So maybe the difference is about 40%. And then for this one down here, maybe this is about 10. This is about 30. So maybe this is about 20%. So these are only my estimates. They're not perfect, of course. So these are percents. But you get just to have something that you can use, roughly speaking. I think those are actually fine numbers. So then how do you use that? Well, the problem is when you go to the choices, sorry, when you go to the different grades, for sixth grade, I'm going to want 60%. But how many sixth graders are there? Well, apparently there's 100 sixth graders, 150 seventh graders, and 100 eighth graders. So notice the sneaky little thing here. This was 150, not 100. So we're going to take 60% of 100, which, believe it or not, is 60. We're going to take 40% of 150, which is also 60. And then we're going to take maybe 20% out of 100. So it goes back to 100 again, and that's going to be around 20. So if you take the total of those, that's about 140. So we can treat this as our target. Now notice it's not the exact number because I was sort of estimating from the graph, and hopefully you guys came up with similar estimates, but D is the closest by far. There's no reason to pick 225, that's definitely way too big. C, maybe, it's at least kind of close, but definitely not A or B, they're definitely too far away. Yes, I am getting your questions. Okay, so slightly harder questions. So this question asks you for the value of y. All right. You have 90 seconds. Okay, good. So some people, I think it's one person for C, several people for E. One person put both E and D. Not sure about that. One person put in a number, which would be incorrect in any case. The answer is either A, B, C, D, or E. So let me show you maybe two different approaches to this question. One is what I would consider the inferior approach, and one's the more insightful superior approach. So the fact is that when you have this question about y, technically we have all the information that we need because we have different values for y. Absolutely, we can just plug in what y is equal to and then figure out what 3y is. So I'll just make a little table here. This is definitely going to be a slow way of doing it, but I think you'll see that's effective nonetheless. So I can just figure out what 3y would be. Then I can figure out what x squared would be. So the way I get x squared is I take 72 minus this previous number. So it'd be 60, 48, 36, subtract another 9 would be 27, or 9. And then finally what I'm doing is I'm looking for something where x would be a prime number. So no, no, 6, no, and 3. But this is the one that's prime, so that means that choice E is the correct answer. So certainly, given the values for y, I can just sort of roll backwards in this equation and figure out what 3y is, then subtract from 72 to find out x squared, and then take the square root to figure out what x would be. And then finally, if x is a prime number, then I know that I have the correct answer. Okay, so the problem with this approach is it requires you to go through all 5 choices. And it's kind of bad luck in some way that the correct answer was choice E. So if you just did this from like top to bottom, going from A to E, you'd actually use the maximum amount of time because you have to go through all 5 choices. So here's really the question for you guys, which is how can I get there faster? How can I know not to go through all 5 answers in order, but how can I know that I should go to this answer first? So what I'm doing here when I go from, when I go from this step to this step is I'm saying that x squared is equal to 72 minus 3y. So for choice A, if I know that y is 4, then 3y is 12. And then if I take 72 minus 12, that means that x squared is 60. But when I take the square root of 60, I don't get an integer because it's not a perfect square, so I stop calculating there. Yeah. But back to my question, how can you know that you should start with choice E first? So another strategy, which could also be time consuming, would be to do this, is plug in for x. So you could just say, what if x is 3, 5, 7, and so on, and just kind of see what happens. Actually, you start with 2. Actually, I forgot 2. So maybe 4, and then I'm going to take 72 minus 4, which would be 68. Yeah, and then what's y going to be? Well, that would be 3y. Yeah, so this does get to the heart of why you can know to get there faster. If I do 3, then x squared will be 9. 72 minus that will be 63. And then y would be 21. And that actually is one of the answers. That's choice E. Okay, I'll do one more example just so you can kind of see why there's something here you can use. If I did x is 5, x squared would be 25. 72 minus 25 would be, what's a good, 47. But then what's y going to be? The problem is, when I get to this last step here, when I get to this number, and I want to find y, the next step in that process is to divide by 3, right? When I got to 68 here, I kind of went, eh. And the reason I did that is because 68 cannot be divided by 3. And when I get to this number 47, I have a problem because it can't be divided by 3. And if I did 7, I'd have the same problem. I'd get a number that's not divisible by 3. So this actually is the shortcut. The shortcut is that I need a number that's divisible by 3. So I'm going to erase everything here and I'm going to go back to the beginning. So looking at the original equation, 72 is divisible by 3. That's an integer. 3y is divisible by 3. That's an integer. So what happens if I take x squared divided by 3? Well, it also has to be an integer. So basically what that's saying is that if this is divisible by 3, and this number is divisible by 3, then this number here must also be divisible by 3. But there's only one prime number that's divisible by 3, and that's 3. So you would actually know that x is 3 right away. You know that x squared is 9. You would know that 3y is equal to 63, and you would know that y is 21. So this property of being divisible by 3, if it works for 2 of the numbers in the equation, it has to work for the third number, if it's addition or subtraction. So with this approach, you don't even, so to answer your question, you don't even have to plug in prime numbers like 2, 3, 5, 7. You would actually already know because this is the only number that's divisible by 3. Now, why did I focus on 3? It's because I have a 3 here. That's the one thing that I actually know. So I would start by saying, okay, this is divisible by 3. And if this one's also divisible by 3, then this one here has to be divisible by 3. This is actually sort of analogous to the property that even plus even is even, right? Only in this case, it's divisible by 3 plus divisible by 3 equals divisible by 3. It's actually the same factoring property. Okay. Example number 5. So this one uses the phrase could be. So for an answer to be correct on a could be question, it has to be true sometimes. It doesn't always have to be true, but just at least once, you need to make it true. So if you plug in and the number is false, maybe it was just false for the number that you chose. What you need to do is just keep looking for numbers and see if you can find if there's any way that you could make it true. And if there's any way that you could make it true, then you select it. If it must be false, then you can cross it out and remove it from the choices. Okay, so let me give you about 90 seconds and wish you luck. Okay, so if you picked one of the kind of lower answers like A, B, or C, it means you're not being aggressive enough in plugging in numbers. You got to keep going to keep finding possible solutions. So there's not going to be one number that works for all of them. You're going to have to kind of change your X and maybe a little bit strategically to find the correct value. So it turns out that the correct answer is choice D. And you have a key fact here that you're going to need to use to help you reason through this. So for instance, they say that x is a positive number. Okay. That actually tells you quite a lot. So for instance, I'm going to look at this relationship right here first, just in this first number. So if x is a positive number, and I know that x squared is less than 2x, I can divide by x if it's positive, and that shows that x has to be less than 2. Okay, so that's my first deduction that I would make for statement number 1, is I know that x has to be less than 2. Then the other thing is I have to realize that when you divide by x, if you want this to be the biggest value, you got to pick a small x. Okay, and the smaller you pick, the better. So you can use decimals or fractions, it's up to you. I think I went with decimals on this one. So maybe if you do 0.1 squared, that's less than 2 times 0.1, which is less than 1 over 0.1. Okay, so that's actually true. So 0.1 squared is 0.01. 2 times 0.1 is 0.2, and 1 over 0.1 is actually equal to 10. So number 1 can be true, and that means we can eliminate choices like A and C that don't have number 1 in them. Okay, so far so good. Statement number 2. Statement number 2, you got to be a little bit more clever because you got to make sure that 1 over x is not too big, but it's still got to be less than 2x. Okay. Now, actually, this same relationship that I made over here between x squared and 2x is still true. X squared is still less than 2x. But the problem is, what I want to do is, you want to make 1 over x smaller. The way that you do that is you make x bigger. Okay. So before when I was looking between 0 and 1, I did a number that was actually pretty small. I did 0.1. Now I'm going to go the other direction. I'm going to go 0.9. So if you do something like 0.9 squared, that will be less than 1 over 0.9, which will be less than 2 times 0.9. So let's just confirm that this is correct. So 0.9 squared is about 0.81, exactly 0.81. 1 over 0.9 is about 1.1. It's actually 1.11 we're repeating. So that's bigger than 0.81. And this will be 2 times 0.9, which will be about 1.8. Sorry, exactly 1.8. And so that's going to be true. So 0.81 is less than 1.1, which is less than 1.8. That also could be true. So 2 can also be true, which means I can knock out B. But now it's going to be either D or E. So between D and E, they both have 1 and 2. We need to focus on whether 3 can be true or not. And now what you see is this relationship gets shifted. So this relationship is now reversed. So what they were saying is that 2x is less than x squared. So now I can divide by x. Again, x is positive, so I'm allowed to divide by x. Now I know that 2 is less than x. So x has to be a bigger number. It could be maybe 3 or something. But now you run into a problem. Because if x is a bigger number, then this 1 over x actually becomes the smallest value. And it does. If I get something like 1 over 3, this is actually false. And there's nothing I can ever do to change this part of it, because you're already constrained by having x be bigger than 2. That means that this number here has to be less than half. But this has got to be more than 4 because x is more than 2. So that's definitely going to be false. Cross out 3, cross out E, and the correct answer is choice D. Okay, questions about that? Okay. Problem 6. So this is a probability question. So what is the probability, and then with emphasis on the not, that they are not two? So I plugged in 0.9 squared less than 1 over 0.9 less than 2 times 0.9. So maybe I should put the 0 in front of the decimal just to make it a little bit more clear. It probably was just too small on the screen for you to see it. Okay. Right, so you guys have 90 seconds. So probability that you do not get siblings. Okay, great. So we have a couple small answers, A and B, and then we have one big answer, E. So before I do the calculation, just a quick sanity check. Is it more likely that you get a sibling or you pick someone who's not a sibling? So if you're one of these 7 people and you randomly pick one of the other people in the room, is it more likely that they're a sibling or that they're not a sibling? Well, clearly, even if there's either one person that's a sibling or there's 2 people that's a sibling, but it's still going to be less than half of the other 6 people. So it's actually more likely that you get someone who's not a sibling. And that's just something you get from sort of the sanity check. There's more people that are not your sibling than there are. So the answers here, like A and B, that these answers are basically too small. So my cutoff essentially is at the 50% point. 50% is the boundary between more likely and less likely. And so definitely it should be more likely that you're going to get someone who's not a sibling. Okay, that's just kind of a preliminary. Next issue is actually figuring out who is in the room. So you've got 7 people, and well, thank you. Yeah, you're welcome. I appreciate it. Yeah, so we have 4 people who have 1 sibling, and then we have 3 people who have 2 siblings. So it basically kind of looks like this. We have a group of 2, a group of 2, and a group of 3. So that's the general situation. Now, when you pick a person here randomly, okay, if you pick someone like A, actually A or B are kind of the same. So if you pick either one of those, there's a 4 out of 7 chance you're going to pick one of these 4 people. Okay, so let me kind of maybe mark this up as a slightly different color. So maybe this group here. So you get a 4 out of 7 chance you're going to pick one of those people. Okay. But then when you pick the next person, out of the remaining 6 people, only one of them is a sibling. So in this case, what we can say is that 2 out of 21. Why does that number look wrong to me? Oh, not a sibling. Sorry, of course. So there's 5 people that are not siblings. Right. So this should be, sorry, 10 over 21. 10 over 21. Okay, I'm going to keep the 21 down here because I'm going to use that later on to compare with the answer choices. Now, the other scenario is that you draw from one of these people. Okay, one of these people in this group of 3. So the likelihood of that happening is 3 out of 7. And out of the remaining 6 people, 4 of them are not your sibling. So the combined chance here is going to be, make sure I got my numbers correct, 6 over 21. Okay. But either one of these 2 cases could happen. It could be that you pick one of the 4 out of 7 on the first try, or 3 out of 7 on the second try. And so then what it means is you actually take the sum. So 10 over 21, and then 6 over 21. This is a plus sign, sorry. That should be 16 over 21. And sure is, it is choice E. $10 over 21. Okay, so in order for me to pick one of the green people, AA or BB, on my first shot, there's a 4 out of 7 probability. Okay, for my first person. That's first. Now for the second person, what you're doing is you're positioning yourself at this slot. So you are person A, right? How many people out of the other 6 people are not your sibling? So one of them is your sibling, but there's 5 more that are not your siblings. That's 5 divided by 6. So then in order to have both of those events happen, you multiply them. So 4 over 7 chance of this happening, 5 over 6 chance of you getting one of these other people, and to simplify the fraction, and you get 20 over 42, but that simplifies to 10 over 21. Mm-hmm. Okay. And then the same logic is for the other branch of this. Okay, so the technique here really is like what's called like a probability tree, if you want to think of it that way. That 4 out of 7 chances for this is one branch, 3 out of 7 chances for this is the other branch. Of course, the 4 over 7 and 3 over 7 make 100%. So you have to pick somebody for the first person. But then it's conditional for the second probability, what that second number is going to be, which is why you have to do this branch in the first place. Okay. So let's talk about data sufficiency just a little bit. So the format of data sufficiency is that they give you a question with missing information. That's really the main thing. And then down below, you're going to have 2 statements, statement 1 and statement 2. Your decision process is to determine whether that information in the statement is actually enough to answer the question that they asked you. So just as actually a very silly example, but just to make sure that the concept is clear, you know, if they ask you something like this, like what's the value of X? One statement might give you an equation for X that looks something like this. The other statement might give you an equation for X that looks something like this. Okay. So the first statement, definitely you can solve for X. You know that X is equal to 2. and that's actually considered enough information. A statement like number 2, though, because of the rules of positive and negative, actually x could be positive 2 or negative 2. This is actually not considered sufficient. Yikes. There we go. More of a frowny frown face. So this is actually considered not sufficient because you did solve for x in some sense, but you got more than one value. What they want is to say that you can answer the question but get a single unique value. So that would not be considered enough information. Then the 5 answer choices give you different combinations of which statement works and which statement doesn't. So kind of as a quick and simple version of it, do I have enough space? I'll try this. Maybe not perfect, but it's okay. Choice A means that number 1 is enough, but number 2 is not. Choice B says that 2 is enough, but 1 is not. C says that 1 is not alone, 2 is not alone, but if you combine them together, they are enough. D says 1 alone is enough and 2 alone is enough. E says basically nothing is enough, not 1 alone, not 2 alone, and not even combining 1 and 2 together. So this is kind of a little short version, hopefully a more visual version of what these statements say. And certainly the first step you should take when you start studying for GMAT Quant is memorize the 5 answers in data sufficiency. Because you don't have time to stop and think about this when you're doing your problems. You need to be able to pick this up and run with it and go, so you can actually focus on the real problem, which is the math in the question. Okay, any questions about that before I move on? Okay. So there's a flow chart based on those answers. And actually, let me just put those up again one more time. And I'll move through this quickly, and then we'll go to an example for sure. But so if number 1 is sufficient, the answer is either A or D. If 2 is sufficient, the answer is going to be either, oh man, I messed that up. I got confused. I tried to be a little bit too clever and it messed up. Okay, so A is that 1 is enough, 2 is not. B is that 2 is enough, but 1 is not. C is that together they're enough. D is individually they're enough. E is that nothing is enough. Okay. Okay, got it. So yeah, so basically your first decision will normally be testing statement number 1 alone. You can change it sometimes, but let's just go with the simple first. So that means that the answer should be A or D if it's enough. If it's not enough, it'd be B, C, or E. Those are the ones that say that it's not enough. And then you test statement number 2 alone, and you can decide whether it's going to be A or D, which would be either D or A over here. If you have B, C, and D left, you would test number 2 alone, and then it will either be B or C and E. So there's actually 2 answers here that are possible. And then you combine 1 and 2 together, maybe C, maybe E. Looks like we lost a couple slashes there. Okay. All right, so example number 8. So they are asking you, is 1 over A minus 1 over B equal to 20? And the answers are, again, on the right side, so if you've forgotten them, they're right there. Okay, 90 seconds. Okay, so that's 90 seconds. So I do have some answers. Okay, a B and a B. Yeah, so let me walk through this with you guys step by step one more time. So just as a reminder, so A means one's enough, two is not. B means two is enough, but one's not. C means neither one alone nor two alone is enough, but together they are. D means that they're each enough separately. And then E says that one and two and even one and two together are not enough. Okay, so what's going on here? We want to know, oh, by the way, I rewrite the answers so they're not alphabetical. I rewrite them so they're corresponding to that first level, that flowchart, AD on the left, BC on the right. So A and D have this in common. They are number one alone is enough. So is 1 over A minus 1 over B equal to 20? Well, it might be or it might not be. But if it is, then this is also true, that you can cross multiply the fractions and basically get 1 over A minus 1 over B is equal to 20. So B minus A over AB is equal to 20. And you can actually take that one step further if you want to. That B minus A is equal to 20AB. Now the thing about this is that you really should keep the question mark here because sorry guys. You really should keep your question mark here because technically speaking, this is not a fact. It's the question that they're asking. It may or may not be true. But if it is true, these other equations are also true with it. But that actually gets you to what you need to know, because when you look at number one, knowing that B is equal to 3A doesn't really tell you anything. It's not the same equation as this equation. So number one is not sufficient. And when number one is not sufficient, that means the answer is either B, C, or E. And you should cross out A and D. Number two, though, is, of course, the same equation. Actually, technically, the proper term for it in algebra is it's an equivalent equation. So if it's an equivalent equation, then it can prove the last line, and it can prove the line above, and it can prove the original statement. So based on number two, we would say, yes, 1 over A minus 1 over B does equal 20. That's sufficient information. So when 2 is sufficient, that means we now know that the correct answer is B. And so I'm going to cross out C and E and just mark down the right answer, which is choice B. And that actually notice that there is no need to combine number one and number two together. Once one statement alone is enough, you don't need to combine them. It's only when neither of them is enough alone that you actually have to combine them. Yeah. Okay. Okay, maybe you've forgotten what your question was by now. That's all right. We're going to have a Q&A section in just a moment, so you'll be able to answer, ask whatever questions you want at that point. Okay, so this is, I think, the last one for me. So this question is asking you if store S sell more than 11 copies on Friday. Okay, 90 seconds. C, interesting. Okay, well, let's let's check. All right, so first fact. Sorry, let me explain how to set this up. So I would typically do this. Just give yourself some slots where you can start plugging in numbers. So we know we're going to have a total of 90. And then what I would do is by default, don't focus on putting them in order like Monday, Tuesday, Wednesday, Thursday. That's not actually useful. Put them in order of smallest to greatest. So smallest on the left, greatest on the right. So what we want is that the greatest number of copies would be on Saturday, right? And the second greatest number of copies would be on Friday. Now we don't know what the other days are, but by default, I'm going to put them in from left to right. So what I want to know is whether store S sold more than 11 copies on Friday. So there's a couple different ways this can happen. So one way is imagine that this is actually equal to 11, okay? And then I'm gonna actually test 12 in just a second. So if this is equal to 11, what are the other possible numbers? I mean, I could put in something like this, like 10, 9, 8, 7, 6. And so this will give you a total of 40, 51, and that out of 90, that means this other number would be 39. Sorry, that's a 9. Okay, so this is definitely a possible set of numbers that could work. Sorry, that's a check mark. On the other hand, I can also make Friday equal to 12. All I have to do is maybe make Saturday just a little bit smaller, maybe make it equal to 38. That would actually also work. So it turns out from statement number 1, I don't know if Friday is more than 11 or less than 11. It could be 11 or 12. And I've got enough wiggle room in the numbers that I can still make them add up to 90 and still have that be possible. So that means that it's not A and it's not D. Okay, statement number 2 says that last week store S sold 38 copies on Saturday. So I can have 38 here. Actually, I can use the same numbers. I can use 38, 12, 10, 9, 7, 8, 6. That's definitely possible for number 2. So there's definitely a 12 that you can get. Can you make it 11 though? Well, the answer is you can't. Because if you go back to this one and try to make this smaller, that means you got to make one of the other numbers bigger. But you can't make 6 bigger because there's a 7 in the way. And you can't make 7 bigger because there's an 8 in the way. And you can't make 8 bigger because there's a 9 in the way, and so on. So going all the way down the line, the only number that you can make bigger would be this one. And if you make it bigger, then it has to be at least a 12. So the answer is that from number 2, you know that Friday has to be at least 12. And the correct answer is choice B. Okay. So I think that's a good place for me to wrap up. Let me hand things back over to Ready for Central. So I really enjoyed today's lesson. You guys have been a really good group, and wish you all the best of luck. And I'll stick around for the Q&A, and I'll be answering questions in the background while the rest of the presentation is going on.